The primary goal of this machine learning analysis is to develop and compare probabilistic models for predicting pulmonary fibrosis progression through forced vital capacity measurements, enabling early identification of rapid decliners and supporting personalized treatment strategies. We are going to be looking at some key objectives such as the model development pipeline, which are using three probabilistic approaches such as the Bayesian regression, the Eddy-Markov models, and the Gaussian process regressions. And we also want to evaluate these models using the MAE, the RMSE, and the R square as well. We will be looking at the fictional importance analysis, which will identify the most predictive factors for FVC decline, including the baseline pulmonary function measurements such as the demographic factors like the age, the sex, the smoking status. And we are going to be looking at what is the clinical relevance for this analysis, which will be translating the model outputs into clinical actionable insight, where we will identify patients with rapid FVC decline patterns, quantify uncertainty in predictions for clinical decision making to analyze the progression patterns across different patient group. We also optimize the model by fine-tuning the hyperparameters to improve the predictive performance while maintaining model interpretability and the clinical utility. So what this analysis will do is that we would be able to use the patient features such as the age, the sex, smoking status, the treatment, the BMI, the blood pressure, the height, and the previous FVC to predict how a patient's lung function will decline over time. And in our notebook, we have installed all the necessary libraries for this analysis, and the next step that we want to do is to do the exploratory analysis, EDA. This is the distribution of the age, the lung capacity, and we have here the age distribution, the FVC distribution, the smoking status, the distribution, the FVC versus time, and also we are going to be looking at the smokers versus the non-smokers, and we would also want to look at how the correlations between all of these features. So what we have here is we have the FVC distribution, we have the percent distribution, we have the age distribution, the smoking status distribution, and also what we have done is that we have used the time series visualization for sample patients. So we have taken samples of 5 different patients to actually see the progression of the fibrosis, pulmonary fibrosis. And all of this was from the data, the pulmonary fibrosis data that was gotten from Kaggle. One really important thing about this analysis is the feature engineering, where we used the age and the smoking to show how older smokers decline faster, and also the treatment over time that slows the slows down decline rate when treatment is being given to the patient, and that is what we are seeing with the FVC progression over time. Now, the next step we want to do is to actually implement our probabilistic model pipeline. So we used the 3 models, and each of the models gave us an RMSE score, an MAE score, and an R square score. So with the Bayesian regression, which estimates how age, BMI, the smoking, and the treatment impact with uncertainty ranges, this also predicts the lung function with confidence interval. In Markov models, disease progression as eating states. So with all of these models, we were able to get the model with the lowest evaluations metrics, and the key result here was that the HMM revealed that 18 patient disease stages showing when a patient's condition is shifted, and the 18 Markov model actually emerged with the lowest evaluation. This kind of modeling helps doctors and researchers to spot high-risk patients early and intervene sooner, and they are able to tailor treatments to individuals. They are able to plan better clinical trials by selecting the right patients. They provide predictions with confidence levels, and this is actually really useful in real-world decision. And from our analysis, it shows that there was a 50 ml or more per measurement. So it tells us that the result tells us that patients with FVC decline rates of less than 50 ml measurements. Basically, what this simply means is that 26% of patients from the data set we got are rapid decliners. So they pretty much lose lung function significantly faster. And what that means is that these patients may need closer monitoring. They may also benefit from early or more aggressive treatment. They may be at higher risk for hospitalization. And in a very simple term, it means that for 1 in 4 patients with this study, it means that they are rapid progressors, losing more than 50 ml of lung capacity per checkup, which is actually a red flag for disease severity. So this analysis shows that machine learning and Bayesian models can actually predict the lung decline in pulmonary fibrosis patients. And also we were able to get the best model for the accuracy